Now, in this case, this is worked example 4.2, you'll see that none of the equations are actually very good for solving. Remember, when we're trying to solve them simultaneously, we're trying to look for a point at which two lines will be crossing. So, in this case, there's one step that we need to do before we solve it via substitution. And that is to make one of the variables a subject. You can either make x equals to something using one of the equations, or y equal to something using the other equation. So in this case, what I notice is that my second equation over here has got an x by itself. And that gives a good opportunity to actually get x equals to something quite simply. So I use equation number 2 to make x the subject, which means that if I take away 4y from either side, I'll get x equals to minus 3 minus 4y. And now that becomes my new equation number 2. It's the same equation, all I've done is I've rearranged it. Now what this means is that for the first equation, instead of x, I can put this expression here. And that's what I'll do. I'll use equation number 1 and I'll say, equation number 1, just to remind us, is 3x minus 2y equals to 19. Alright, now instead of x, I can put this expression. So, this is what I'll do. I'll go 3 brackets minus 3 minus 4y minus 2y equals to 19. Notice how I keep all my signs the same way. Crab clause. So 3 times negative 3 is minus 9. 3 times minus 4 is minus 12y. Minus 2y equals to 19. Now, collecting like terms, that ends up being minus 14y equals to 19. Okay? And what I'll do now is I'll have to stop the film and I'll start again from the top because I think that this might be out of the frame.